Thanks for tuning in to today's Chai Chat. Today, I have the pleasure of hosting Mike Farian, who is an IoT hardware leader. He has extensive knowledge and experience in harnessing the power of IoT to drive decision-making across enterprises. He will be sharing his valuable insights today on the potential of IoT, its impacts on various industries, and how data analytics can unlock its full potential. As you all know, this is more relevant than ever. In today's rapidly evolving landscape, the Internet of Things and AIoT have become crucial components for organizations across industry. So without further ado, let's dive into today's Q&A session and explore the fascinating world at the intersection of IoT and data analytics with Mike. Mike, would you like to share a little bit about yourself and tell us about how you got into this field and some of your background and experience in it?
Yeah, you bet, Naomi. Thanks for having me today. So I started my career as an electrical engineer designing products for what we used to call the machine-to-machine communications market, right? So there's a lot of automation, remote monitoring type things. And that all started with a lot of wired products, but then over time, it also started to leverage wireless technologies as they became more mature as well. And then, not to date myself terribly, but it was around the year 2010 or so, I started to really see a shift in that world of machine-to-machine communications. So it used to be all about what we call OT, operational technologies, in comparison to IT, information technologies. But what I started to observe then is we were starting to get inquiries and have interesting conversations with whole different types of companies than we used to. We were getting calls from enterprise IT type companies who up until that point had been entirely focused just on traditional networking, right? Computers, laptops, servers, that sort of thing. But what they were starting to get interested in is acquiring data from the physical world, sometimes from the machines out on their factory floor or from sensors and things like that. So all of a sudden we're getting inquiries from more that IT and enterprise type company. And I couldn't really put my finger at it at the time, but looking back at it now, what that was the very front end of what we now call IT-OT convergence. It was also the very front end of what we began to call the Internet of Things type technology, which today we still talk about that term, but also maybe a more encompassing term of digital transformation. So yeah, it was a really interesting period of time. And because of those conversations, we started to realize that there was a new opportunity emerging in front of us to start thinking about getting edge to cloud and edge to enterprise software type connectivity instead of just from machine to machine sort of connectivity. So that changed our products, our technology roadmaps, and we started really designing products specifically for that edge to cloud environment, maybe arguably even 5 or 6 years ahead of when we should have, because it was a longer, slower journey than we may have thought it would. But then through that process, then the company I was with at the time, we were acquired by one of the largest industrial PC companies in the world. And that gave me some great opportunities also to go beyond just the communication side, much deeper into the world of edge intelligence, both CPU based and then GPU based. So that gave me another kind of layer of foundation on top of all that wireless communications experience that I had gained.
Amazing journey, Mike. We can't wait to dive in. So level set for everyone. What do you mean when we say the Internet of Things, or there's so many abbreviations now, IIoT, Industrial Internet of Things, IOMT, the Internet of Medical Things. So how do we define these, and how is it revolutionizing some of the traditional platforms?
Yeah, it's a great question, because IoT really became a bit of more of a marketing term than a technology term, right? So it's a little bit of all things to all people. But if you zoom back a little bit, it's pretty easy to grasp. So if we go back into the history of networking computing, and we're not really going back that far here. So in the 1980s and the early 90s, we started out by first in the 80s, the PC was born, and the concept of having a computer on a desktop, which was brand new to the world, became a thing. And then we realized if we start hooking all these computers together, they have tremendously more value than just a standalone machine on your desk. So in the 80s and 90s, we networked our computers, right? And then we got into the early mid 2000s, and smartphones, came along, and at that stage, we started networking people. So that unlocked a whole set of things. You could argue some better than worse, but things like social media, e-commerce, all those things were born as a concept of first networking computers and networking mobile devices. The next logical step now is networking things. So we have all our people connected now. We have all our intelligent equipment connected. But what about things are at the very edge of networks? I'll use some consumer examples. That's not really my space, but sometimes it's easier for people to grasp. But the fact that you have a Ring doorbell, for example, or a sensor in your mailbox that tells you when mail's been delivered, or in the agricultural world, maybe soil moisture sensors. You're getting data from the physical world, and we're connecting that through internet level technologies, IP-based technologies, ultimately into the same kind of cloud computing platforms that we're using to run our businesses today. So if you zoom back and say, first we networked computers, then we networked people, now Internet of Things, getting to those edge level things and devices is kind of what the IoT is all about. And then you can throw those other terms in front of it. Is it industrial IoT? Is it medical IoT? And things like that. If you zoom again, it's really, I really like the term digital transformation, because I think it's much more actionable, because IoT is almost like all things to all people, where if you look and say, well, what we're really trying to do with IoT is perform digital transformation on these companies.
Yeah. Well, I got my smartphone and my wearable right here, so
Exactly.
I'm fully connected.
Right.
Now, you touched on a few already, Mike, but tell me about maybe 3 of your favorite, either the most fun, most unique, or most impactful IoT use cases that you've had the chance to work on, perhaps across a few different industries.
Yeah. Good question. That there's been so many interesting projects, and some of my, I hesitate on some of them, because some of them that were a lot of fun and really interesting weren't necessarily commercially successful. So let me kind of zoom in on the things that were more meaningful. And I kind of broadly put them into 2 to 3 categories. One that is really pretty fascinating is just the high level concept of connected services. So there's a lot of companies out there that the core of their business is some sort of field service. They got people in trucks and vans, out in the field, driving around, going out to customer sites to fill something, to empty something, to service something. And the way that has always traditionally worked is calendar based. Every Monday, Wednesday, and Friday, this person's going to show up and perform this task. And there was a lot of technology. I would say one of the very earliest applications of what we call kind of IoT today was around what we call the telematics industry, putting a GPS and communications into a vehicle so we could track where that vehicle is, some insights about that vehicle and driver behavior and routing efficiency and things like that. That was kind of first generation IoT type stuff in the very early 2000s. But today it's a whole different thing. It's not just about making that existing route more efficient. It's can we shift that from calendar based field service to truly demand-based field service? And one thing we really saw post-pandemic is that the tragedy of the pandemic was also an accelerator. It kind of sprung us forward probably a decade or so in some of these applications of technology. So if you imagine you're a company now and you have your largest single expense is your truck rolls, putting these people in vehicles, getting them out to the customer sites. And they're going out there every Monday and Wednesday and Friday to do something in a commercial building, for example. And all of a sudden, during the pandemic, you couldn't get trucks. We have driver shortages. You couldn't get into those buildings. Now, post-pandemic, we still have shortages of drivers. The supply chain of trucks is coming back now. But we're all in this hybrid work environment now. So it doesn't necessarily make sense if you're in the controlled documents management space and you're going out and taking care of the paper shredders and all that sort of stuff, maybe in the financial industry, and nobody's in that office on Tuesday and Thursday that week, or it's every other week, or things are changing around on a monthly basis. That no longer makes sense. So getting to some sort of connected services is really interesting. So putting a sensor in that bin, putting a sensor in the pest control traps. Think of a food processing plant, and they've got all kinds of pest control. It's not a pleasant thing to think about, but these bait stations, for pests, and how you need to go service these things, you need to rebait them and take care of them and things like that. what if you can have that edge device tell you when it needs service and then integrate that into your business process automation such that you're getting away from calendar-based visits to truly demand-based visits. So you're now aligning your resources with your actual value proposition in a much more elegant fashion. So there's a huge space just that I call connected services. That's really, anybody that has a large fleet of vehicles, in their company should be thinking about that, because it's the second order effects are obviously huge as well when you think from an ESG perspective, right? And environmental impact and things like that, and just making best use of resources instead of paying people just to sit in a vehicle and go to a site that may not need any value add services performed. So that's one big category, and there's lots of great examples in there. Another category is the whole idea of connected products. So similar sort of space, but this is more a machine builder. So somebody that makes commercial kitchen equipment, right? They're making the fryers for the back of a quick serve food restaurant, or they're an industrial air compressor manufacturer. So these people would like to have more insight into their hardware, that CapEx type equipment that they sell after the sale. And there's a number of reasons for that. One is they want to get better customer insights, better customer intimacy that they can use to design into their next generation products. They truly want to understand how their products are used, in the field. They also have warranty costs, so another service model. So they want to have more efficient and better customer service to their customers. So when they get that call that says, "Hey, my this compressor, it's under its manufacturer's warranty and it's not behaving properly, you need to send a truck out here." If they can have a connected product, they can see, log into a dashboard, and they might see that, hey, there's just a preventative maintenance cycle that you guys missed, and instead of us sending a truck out here, you just need to change this filter, for example. So you get a better customer experience and reduced service costs in that case. But it's also for some of these companies, and these are sometimes the most fun, a lot of these companies have a longer term vision. So take that air compressor manufacturer. So industrial compressed air is a huge electrical consumption in America and around the world in manufacturing. But it's generally sold as a CapEx sort of thing. You buy a 200 horsepower compressor to provide a certain amount of compressed air. But nobody in a factory says, boy, I want to grow up and buy an air compressor someday. That's not their goal, right? They want to produce widgets. That compressed air manufacturer looks and says, look, we want to have a connected product. Today, our value proposition or our ROI, the way we're going to fund this is because we think we can reduce our warranty costs and our service costs. But in that process, we're going to start to collect a lot of data about how our equipment is used. And then we think over time with that data, we could have a roadmap to the point where we might be able to sell compressed air as a service instead of selling it as a CapEx, and try to figure out how to better match their financial model with their customer's financial model, for example. So it's really interesting. I really think of it as these connected services, connected products. It's a journey because you start by getting some short-term ROI that you can get from that data. But as you know all too well, once you gather this data, you can start to gather more insights, and then start to figure out how can we use insights like this to better match our offerings with our customers' demands. And that might be, not just the technical things, but also, making the financial models align better. Probably the third category that comes to mind is, and it's maybe a little bit of apples and oranges, but I really get excited about the more mission-driven type applications. It's always, all these things, it's about getting more efficiency and cost savings or compliance or finding new revenue streams. But the ones that are kind of more clearly mission-driven are always kind of especially motivating for me. And there's a lot of examples around this, a lot around water management, smart agriculture. There's just a lot going on there. Tons of great examples, whether it's around water management, using things like soil moisture sensors, and getting really discrete, instead of treating 500 acres all as one thing and treating it exactly the same way, being able to subdivide it and say, look, there's a whole lot of different ecosystems here that need different levels of treatment, that I could use a lot less harmful chemicals, I could use a lot less water, I could have a lot less harmful runoff and things like that. Weed control, this is a great one around AI. Computer vision is a relatively mature side of AI today. And we start by in a field, spraying all the crops with a herbicide, right? And obviously that's not great for anybody, but they do need to control weeds. Well, if you put a camera on those sprayers and able to control each sprayer independently, now you can just spray the weeds, not spray the corn itself. Just go through and look: is that a weed or is that a corn? Is that wheat or is that corn? And spray the right thing. Some companies now are going a step further now and eliminating the herbicide altogether and using a laser, which sounds like the coolest thing ever. It's something I'll actually watch, and they're literally blasting the weeds with lasers and getting down to zero.
Wow.
Yeah. So there's all kinds of ways where we can, this Internet of Things, when we reach out to the very edge and get data from edge things or devices, or right, then all of a sudden we can start to really optimize environments and get insights that we can use to create all kinds of new opportunities.
Amazing, Mike. I love everything you're saying. And I love that you were able to connect it to the mission-driven missions like water conservation, so critical, so impactful. And I think you nailed it on the head with the connected services, the connected product. We did similar things at GE Healthcare, having the CT machines, MRI machines, being able to get the data from those. How are those machines being used? How are their components doing for preventative maintenance, as you mentioned? So I think this is definitely the future, and all enterprises need to be thinking about this as they think about the future of their business models, which you also touched on, have the opportunity to evolve by leveraging IoT and AIoT. So just absolutely fascinating. To drill in a little more, Mike, can you talk about a few of the fun sensors you might have worked with, and maybe some challenges with different types of sensors?
Yeah. So the sensor world is vast, right? It's in the ballpark of an $80 billion market in itself. Hundreds of thousands of different component part numbers and thousands of suppliers. The ones I've focused on the most are the ones that have an application use case that really fits well with a wireless technology, to say, look, if we could take the sensor and put a radio on it and a battery or some sort of way to power it without plugging it in, and now we can put it out in this field. We can put it in a pipe, measuring, looking for leaks, looking for measuring flow, things like that. So it's really pretty vast. Temperature still remains absolutely the number one use case. And even the world of temperature sensing is pretty vast, with probably at least 4 or 5 different fundamental physics technologies used to measure temperature, depending on, are you measuring air temperature? Are you measuring soil temperature? Do you want to know the temperature of the food around that's being surrounded by that air? And you use a little bit of machine learning models actually to do that, to say, well, in a freezer full of salmon, I don't really care what the air temperature is if I'm storing that safely. I really care what's the core temperature of the food. So when that door opens and closes, the air temperature changes quickly, but the salmon temperature doesn't change that much. But if that's a case full of milk, it has a very different profile than salmon does, for example. So even something seemingly as simple as temperature has a lot of different complexities to it. But all kinds of things, flow rate, pressure, air quality is becoming a hot topic. As today I sit in an environment because of the Canadian wildfires where it's actually getting to the point of being dangerous to be outside. Just a huge array of sensors, and sometimes we integrate these right into a radio, and build that all together. In other cases, we say, look, let's build a radio device that can interface through a standard industrial protocol, just like what we'd call like a 4 to 20 milliamp current loop or a 0 to 5 volt analog signal. So now we can plug in any industrial sensor and tie it into this radio technology for remote access. One area that's actually fascinating in sensors is the idea of using cameras as a sensor. And, so we are all pretty familiar with all the different applications around video, and especially now we can couple that in with machine vision, AI type technology becomes really powerful tool. And we're all familiar with a lot of those applications, but they don't all have to be high resolution, 4K cameras. We've got an example where you can take a very low end, very simple camera, like 100 by 100 pixels or so, and use that and it's small enough and generates a small enough amount of data that we can put it in a battery powered device and use it to count how many people are in this conference room, for example. And the important thing about that is we could do it with a high resolution camera as well, much more cost and expense. But now you open up, do we have privacy concerns with that? With a 100 by 100 pixel camera, there are no privacy concerns because you can't do any kind of identification based on that. You can just kind of count heads. But so using cameras as a sensor is really pretty intriguing as well. And some sensors are, one of the challenges are some sensors are pretty static, right? Like a temperature sensor, just saying, okay, this isn't changing super fast. Other sensors are much more dynamic. So think like a microphone or a vibration sensor to monitor machine condition, sort of things. Those sort of sensors have to collect a lot of data. They need a whole lot of samples and need to do some analytics on that before you can draw any conclusions. If you're going to use a sensor like that over a wireless connection, especially a low power wireless connection, it gives you some interesting challenges and use cases where we say, okay, we need to think about doing a little more processing at the edge because we can't possibly send this much data up over a battery powered connection and expect to have that battery last for years and years. So a lot of different challenges. There's sensors for every applications. There's sometimes the question doesn't start with the sensor, it starts with the application. So if you're designing a next generation connected product that's a pest control bait station, now you need a mouse sensor. You can't go into the DigiKey catalog and search on mouse sensor. There is no category for that. So you need to think through what's the best way to detect presence of a rodent, and how do you distinguish that particular rodent from insects or other things that aren't your target, so you don't have false negatives or false positives and things like that. So a lot of great and really fun application engineering level challenges around that.
Yeah. And you've mentioned the edge a few times, Mike, now. So let's define it for everyone. What is the edge? Where is it? And then talk to me about some of these AIoT use cases and the various ways they can be deployed, basically in the cloud, on the edge, and how do we decide what to deploy, when, and where?
Yeah, that's a really good question, because a lot of people have such different visions in their head around where the edge really is, right? So if you ask somebody in telco where the edge is, it's out of their like distributed data centers, but to me that's much more like the core than the edge. To me the edge is all the way out there. It's in that soil moisture sensor that's 3 feet underground out in that farmer's field sort of thing. So you do get a lot of different questions to that. And then when you start thinking about design challenges, okay, what does this mean? And when we say edge intelligence, how much intelligence are we talking about, and where are we putting it? And you really can start to draw. You almost have to start to draw a little system diagram that starts with your sensor, and then in some cases maybe that sensor is connected directly to the network. Perhaps that sensor has a cellular connection on it, for example. But in other cases, you don't have enough power to do that, so you might be using a low power sensing network, and that means you're going to have a gateway someplace. So now that gateway becomes part of your edge. So now you got the sensor. We have some capability to put intelligence there. You also have a local gateway, and maybe that's a place we want to put some intelligence. And then you're going up to your, likely up to your cloud type applications and different levels of intelligence there. So when you think about where to put how much intelligence, there's a few different dimensions I think you take into account. One is that every one of those steps is how much bandwidth do you have, and what does that bandwidth cost you? So if you've got a LTE connection, to your moisture sensor out in the field, you've got lots of bandwidth there, and the amount of data that sensor is going to produce isn't that high. So you probably don't think that much about, hey, that's going to cost me a really expensive data plan. Sort of thing. But what if that sensor is on a ship, and the only way it can communicate, it's communicating locally onto that ship over a technology like LoRaWAN to a gateway, and that gateway's backhaul is a satellite connection, super expensive connection. So you don't want to be sending a whole lot of data there. So that, so in that case, you need to put more of your processing intelligence down at the edge. So depending on how much bandwidth you need to support your structure, and then also the cost of that bandwidth will help determine like where should you put some edge intelligence. So that's one dimension. The next one is power. So if you come from the world of enterprise and IT, you don't always think so much about the challenges of power because you typically have, either mains power or PoE power available at just about any place you go. But again, if you're on a sensor, in a refrigerator, you're buried underground, you're, in a pest control trap, you're typically going to be in some sort of energy harvesting or battery powered sort of environment. So now you have to think about, well, first, it costs power to have edge intelligence, right? You have to have a processor that can wake up and process some data. What costs more power is to transmit data. So it's quite power intensive to fire up a little radio transmitter and have to send a lot of data. And you can reduce that amount of power by reducing the amount of time that thing is on the air. So you want to try to keep its data down to as small as possible. So that might imply like, hey, we want to have a trade-off here. Think of that vibration sensor example. Yeah, I need to wake up and sample 10,000 samples very quickly over maybe a 1 second period of time, but I'm not going to send all 10,000 samples. I'm going to perform a little Fourier transform, on the processor right down here in the unit, and then just send the results of that transform up over the wireless network. The third dimension to think about there is security. So it's kind of the data provenance thing of at what level is there layers of risk of sending this data further and further up the stack, if you will. So again, thinking of a camera in a fairly secure location. So I want to know how many people are in this conference room, but I don't want to have any risk that somebody could misuse this data to actually do facial identification and things like that. So now I might want to say, okay, I need to keep that data down to, I'm not going to send an image all the way up because that would be expensive because of the large size of the file, but also it opens the door to different misuses of that data. I just want to compile that data and send up a number that says 5. Right now there's 5 people in the room. It doesn't, there's no way somebody can reverse engineer who those 5 people are in the room, for example. A common example of that would be a very mature application now around like license plate recognition, right? So if you have a camera put in at an intersection or coming into, Chicago is wonderful now. They check your license plate on the way into the airports to be sure you don't have too many parking tickets, right? But does it make sense to send the full image of every vehicle up to the cloud, or to use a little bit of machine learning, a trained model that you embed down at the edge, maybe even right in the camera that says, hey, look, it has this model in here. And instead of sending a 1 or 2 megabyte file up, it's just sending something up with, here's the 6 digits of this license number sort of thing. So, literally 1,000,000 to 1 sort of compression on that by pushing that down to the edge. And if that camera might be in a battery powered installation, with a solar cell and a battery to get it through the dark days and nights, keeping that thing off the air, that might have been a 5 or 10 times reduction in the size of battery you needed and the size of the solar cell needed to keep that battery charged up. So looking at those 3 dimensions, I think in terms of what level of intelligence do you want to put where in the system, and it really comes down to, where are your bandwidth constraints, both how much bandwidth you have and the cost of that data, where are your power constraints, and then what's your data policies, and what are your data risks around that.
Thanks, Mike. Yeah, great framework looking at all the different components on deployment. You also mentioned LoRaWAN, so let's get into it. For those who like to get a little bit technical, we've heard 2G, 3G, 4G, 5G, cellular, wireless, LAN, WAN, LoRaWAN. What are all of these things, and what do they have to do with IoT? And how has it evolved from the conception of IoT?
Yeah, it's a good question, and it's gotten the bad news is it got really confusing for a while because we had lots of people trying to come in and invent something new to solve a problem. The good news now is it's really consolidated down to say the market has kind of spoken and nominated some winners, so we don't have to learn 20 different things. You can boil it down to just a handful. So first is the world of cellular, right? So 2G, 3G, 4G, which we also call LTE, and then 5G, which has been all the hype, for the last few years. So G stands for generation, and pretty reliably every 10 years we get a new G, right? So 2G and 3G added some more data capability. 4G is really what enabled smartphones with LTE. So we had enough bandwidth now that we could do all kinds of fun applications on smartphones. 5G takes that a whole nother level and opens up a whole nother set of applications. But it's all in all, it's always been about getting more bandwidth out to the device. And also, from a technology perspective, getting more spectral density or more use out of the airwaves that we have. So, just making things more and more efficient so we can get more data across there. One thing to keep in mind with all these 2G, 3G, 4G, 5G things is they're not backwards compatible. So what that means is as the cellular companies move up, and move forward in the technology set, they have to start unplugging things behind them because they need to recycle that space that they used up with that inefficient 2G and use it for their 5G networks. So when you're in this industrial IoT world and deploying maybe a wellhead monitoring out in the oil field sort of thing, that might be out there for the lifespan of a well of 10 or 20 years. It's sort of bad news for you when you get that letter in the mail from your cellular carrier that says, hey, look, that 2G network that you've got 8,000 devices on is being unplugged. And those devices are all going to go dark on you. So you're going to have to do something about it. So that's something to be aware of. Now, they don't come that fast. Like I said, every generation technology is only coming every 10 years or so. But we've seen 2G shutdowns, 3G shutdowns already. So just something to keep in mind on the cellular technologies is you're renting, just like on your phone, you're paying a monthly charge to get on somebody else's network. So the great news is they're managing all that for you, the quality of service and the coverage and all that. The bad news is when they decide to move on to the next generation, you need to move with them. So that's kind of the world of cellular, and it has a lot of play in the IoT space. But there is a gap left underneath cellular. So while cellular is focused on more, faster, better sort of thing, there's a lot of things that said, that wellhead out in West Texas, where there's far more wells than people, it needs to communicate, but it only has a very small amount of data. And it's also, some of these applications are really cost sensitive. You want to put a soil moisture sensor in a field, you don't want to have to buy a data plan for all 1,000, sensors that you might put out in a field. So there's, it's really been developing over the last 20 years, but the good news is over the last 5 years, it's really zoomed in. So we don't need to talk about 5 or 10 different kind of wireless low power technologies for sensing anymore. We can kind of zoom in and say, look, in the last couple of years, the market has really spoken for the commercial and enterprise world. LoRaWAN is really becoming the dominant wireless sensing technology. And what LoRaWAN is, it was designed from the start to be a sensor level technology. So it's a gateway based architecture. So it means that someplace you have to have a gateway in range of these sensors. And the sensors will communicate up to that gateway, and the gateway will take that data and forward it up to your IP-based network. The great news about LoRaWAN is its range. So in an outdoor setting, you could easily have 10 kilometers, for example, of range for a gateway. So think of smart cities, smart metering applications, things like that. It also has great in-building coverage. So if you're deploying wireless sensing into a multi-story commercial building, maybe you're going to do leak detection sort of thing. You're trying to get a break in your insurance rates after a couple of bad plumbing accidents. You could put in maybe one LoRaWAN gateway per floor, maybe every other floor or something like that, and get complete coverage into a very large commercial building. And then be able to attach these different battery powered sensors and things that way. So LoRaWAN has really become the dominant for the non-consumer world of IoT. If you open the door into home automation and consumer electronics, then we have to open up the door into a whole bunch of other topics, but those usually don't translate well into the commercial world, where when you're doing an IoT deployment in the commercial world, it's almost by definition business critical. Home automation type stuff is not business critical, sort of thing. If something goes down for a little period of time, it's annoying, but it doesn't hurt your ROI in any big way. In the commercial space, first you have bigger spaces, longer range, and more cybersecurity things to worry about, more longevity concerns to worry about. So things tend to be, by definition, business critical. But I'd say that kind of covers the main technologies. Wi-Fi still has a big play. It's not so great for sensors because it's quite power hungry. It's not so great for non-human interface devices. That a lot of people are tempted to use Wi-Fi for some of these applications. And we do see it in the consumer market more. But the bad news in Wi-Fi is all of us have experienced somewhere in our career that says, look, IT just made a new policy change. We're going to have to start changing our passwords this often. Hey, we're moving from this level of security to this level of security. And they say, hey, this is going to happen to all your machines on Sunday night. Don't worry about it. We've got remote management. We can take care of it. Well, if you got some cellular or Wi-Fi based air quality sensor, it didn't get that email. All that happens is it comes in on Monday morning and it's no longer on the network. And the only way to get it back is for somebody to go physically visit every one of those sensors and figure out how to reconfigure it. So Wi-Fi still has a great place, and obviously we use it for all of our business machine type networking, but it's not so great for unmanned type equipment. And Bluetooth is the other one that definitely deserves a mention. There is so many Bluetooth applications out there that we're unaware of. You can download for free like a Bluetooth sniffing application on your phone, and it'll just listen for these things called Bluetooth beacons. Walk into a big box store or your grocery store and see how many Bluetooth devices are around you, just beaconing everything from smart labels, the freezers, there are so many Bluetooth applications out there. And a lot of times we see a convergence where we say, hey, what if we use a combination of Bluetooth and LoRaWAN in a single product? That's becoming very common. Really allows you to open up a lot of use cases, and it's quite cost effective.
Thanks, Mike. I think finally everyone can get their head around this, and really interesting to see how you can mix and match them as well. So to wrap up, if some of these enterprises, are not already underway in these initiatives, I think they'll be taking it up soon. So what fundamental skills, qualities, best practices can you share, or would you say are required for a successful implementation of an IoT, AIoT project?
Yeah, it's really interesting. So, anybody that, if you go back just a couple of years, there was a lot of studies and a lot of articles about the really high numbers of IoT proof of concept and pilot projects that never made it to production. It was in the 70 to 80% failure rate sort of thing. And I, being so early into the IoT, I feel like I was involved in a huge number of those. This seemed like such a great idea. We were all so excited about it at the time. Really focused on the technology, and then what if we had this data? Of course, here's all the things you could do with it, and deployed it. Made it work in the field, and then found that it never really went to production. And when I rewind on those, and I've spent a lot of time thinking about that, the number one challenge there was change management. So certainly there was technology challenges and integration. Everything is always a little harder than you think it's going to be going in. The good news is all that stuff has gotten progressively better and better. It's still some effort involved. I mean, you need choose your vendors wisely, choose your partners that can really be consultative with you. You don't want just a vendor here. You want a strategic partner that can help you with your architecture. You leverage their knowledge at every step along the way. But as much as anything, when you start thinking about the whole point of the IoT is now we're going to bring data to you that you previously didn't have, at least not in scale. So we're going to start getting data in much more data in real time, and lots of the saying that data, it's a little dated now, but I just ran across it this morning. Data is the new oil sort of thing. Like I disagree with that. Data enables new things, but if you have a pile of data, all you have is a pile of data. So first somebody has to do the analytics around this data. But then you have to do the hard work, and the hard work is now we need to adapt and transform our business to leverage this data. So, if the IoT is dominantly around, finding ways to do things more efficiently, nothing's more efficient just by having big files of data on your computer. So you have to go in there with a strong change management, viewpoint, and you need to have everybody on board, because at the end of the day, you can't get around the fact that in most of these cases, that gaining that efficiency, your number one cost is the cost of human capital. So that means you're going to have people whose jobs are impacted. You're going to need to find new opportunities for them. Can you reskill some of these folks? And it's the right thing to do. It's happened for, we all used to be farmers long ago, and we figured out how to really automate farming. And we used to have hundreds of thousands of people at telecom switchboards, and we decided that was something that could be done through automation. So these things are It's the reality. But where you find companies that aren't successful is when they say, okay, we have this data, we've proven our business case, but what we failed to do is convince the various management teams and onboard all the different teams and say, look, this is why this is a good thing. And we're going to change our business processes around this. We're going to use this data to continually adapt and improve our business and really, look forward into the upside of all this. I think that's been the number one cause of failure is companies that have not been ready to embrace the change management that's going to come. If I go back to my connected product, connected service example, I always consider those a journey because, and it's the companies that are most successful are the ones that recognize that, hey, this is a journey. We've had examples where, they start out and say, look, yeah, I want wireless connectivity into my dispenser, right? And I've got service people that are going out and refilling these dispensers. But to start with, I don't want to spend the money to have it actually be an IP connection up to the cloud. All I want to do is put Bluetooth in it. So now that same person is still going to follow that same route and they're going to go to fill these dispensers, but all they have to do is walk into the room that has these dispensers and their tablet or their device is going to tell them that, look, these 6 dispensers are full. You don't even need to open them or touch them. These 4 need service. I'm just going to take that existing business process we already have and we're going to make it more efficient. That's a pretty easy thing for a business to swallow. And then down the road to say, okay, now maybe I want to take that data and bring it to the cloud. So now I can reroute these people and only put them to places where and when they're needed. That's a much, much harder set of business process changes to do. Recognizing that you can do that, lay out a roadmap of stepping stones to that is a really mature way to go about it in my mind. Because change, the technology is not easy, but it's getting easier. But change management is always hard.
Very critical change management. I think you nailed it on the head, Mike. And another key point you hit on, that idea of you need to operationalize it to really monetize it or see the benefit, right? So how do we make sure that those insights are embedded into the business process, and how do we make it also consumable, palatable for the business to actually adopt it and go on that journey?
Yeah, exactly.
Thanks again, Mike, for joining me today and sharing all of your knowledge and your wisdom with all your great experience. So I think it'll definitely help us accelerate our initiatives. And for those who are looking to create their own IoT, IoMT, AIoT solutions, feel free to reach out. Until next time, thanks again, Mike.
Thank you, Naomi.